Alright, hi everyone. So we're going to cover long division today. With the warm-up, the first two are going to be a review of yesterday, and then the third one is review of long division, so that we can kind of set up for dividing polynomials. So, why don't you pause the video and see if you can do numbers 1, 2, and 3, and then when you're done, unpause it and check your answers. Okay? Alright, so let's check your answer for number 1. First, factor out a negative. Okay, this has to be a 2x and an x. This is a 9 and a 2. Nope. Sorry, that doesn't work. You can't have a 2 with a 2. Let's switch them. So this is a 9 and this is a 2. So that gives me 4, and that gives me 9 minus 4 is 5. Okay, so this solution would be x equals, and subtract 9 divided by 2, and then x equals 2. So I want to draw a sketch of the function. Because this is x squared, it should look like a parabola. Because this is negative, it should look like a parabola going down. So negative 9 over 2 is negative 4.5, so somewhere over here. Positive 2 is somewhere over here. And then through the point and through the point, make sure that it looks like a looks like a symmetrical U. Okay. All right. In the next one, look to see if there's a GCF that you can take out. There is not one, but out of these two, I can take out an x squared. Out of these two, I have to take out a negative because the leading term is negative, and I can take out a 16. Okay, so I take out an x squared. I'm left with 2x minus 3. Take out a negative 16. I'm left with a 2x minus 3. They're identical, so that means I can group those together. So I have x squared minus 16 times 2x minus 3. Okay, from here you can solve, or if you want to factor further, you can factor this right here as x plus 4, x minus 4, 2x minus 3. That way you can see all of your solutions. So x equals plus or minus 4, and x equals, add 3 divided by 2. Okay. Oops. So I have my solutions. So we make that negative 4, that positive 4, and that 1.5. So back up at my original function. 2x cubed, so it's positive, and it's cubic, so going different directions. So I'm going to start down and end up. So something like that. Okay. Alright, now let's look at the long division. Okay, so I'm going to divide 9, 2, 8, 4 by 20. Okay, so 20 does not go into 9, but 20 does go into 92 4 times. Multiply 4 and 20, you get 80. Subtract, you get 12. Bring down the 8. 120 goes into 128 6 times. 6 times 20 is 120. Subtract, you get 8. Bring down the 4. 20 goes into 84 4 times. Multiply, you get 80. Subtract, you get 4. So that's my remainder. Sorry, it's my dog squeaking in the background. Alright, so your answer then is 464. with a remainder of 4, which we would then write as 4 out of 20, which we can simplify to 464, and 420 simplifies to 1/5. So then 464 and 1/5, you could write it as a decimal and write 464.2 as well. Okay, so this is my remainder. And your remainder you always put over your divisor when you're left with something. Okay? Alright, let's look at some of the problems today. So if you were given excuse me, if you were given this problem and you were told the same thing as number 1 and 2 in the warm-up and told to find the zeros, the only thing that we could do is factor by grouping. There is no GCF, so I'm going to take out an x squared here, and here I'm going to take out a 2. So if I take out an x squared, I'm left with 3x plus 16, and then I'm left with plus 2, I'm left with 9x plus 4. Okay? Notice that these two are not the same, and if those two are not the same, then I can't group together the x squared and the 2. So, if I can't factor this by grouping, then it means that this is not factorable. So, not factorable. So then the question is, how do I figure out what the solutions of this function are if I can't factor it by grouping and solve? Well, last year when we couldn't factor, we had other methods. We used completing the square, which we can't do because there's 4 terms. We also used quadratic formula, and I want to make a note here. Cannot use quadratic formula. Okay, we can't use the quadratic formula because this isn't a quadratic function, it's x to the 3rd power. Also, quadratic formula uses a, b, and c, and this has an a, b, c, and d. So we can't use the quadratic formula, so then what do? So this is where we use polynomial long division. Okay, and it gives us an option to be able to actually come up with a solution. Okay, so first thing, we want to give ourselves some room when we do these. They're going to take a little bit of room, so try not to cram any numbers together. I try to give you plenty of space here. So we want to find the quotient of x squared minus 5x minus 20 divided by x minus 4 using polynomial long division. So we're going to start with writing out x squared, but again, give yourself some space. 5x minus 20. Notice I'm spacing my numbers apart. And we're going to divide this by x minus 4. Okay, so here's the thing with polynomial long division. I want to always get rid of my leading terms. You're probably going to have to watch this once or twice before you kind of get the hang of it. So I want to figure out how to get rid of my leading term. Whatever I put over my term, I have to put as a like term. So for instance, above this, if I want to put something here, I'd have to put an x squared. I could put a 2x squared, a 3x squared, a 4x squared, but the variable has to be an x squared. The problem is, when I go to multiply by both of those terms, x squared times x gives me an x cubed here, and then if I subtract those don't disappear. So that's not going to work. Okay, so let me take that away. So let's say I go above this term, and because that's an x, I write a like term and I make it an x. Well, now if I go and multiply, x times x gives me x squared. And notice those are identical, so when I subtract, they'll disappear, which is what I want. X times negative 4 is negative 4x. Okay, now, I need to be very careful that I subtract this whole quantity, so you always want to make sure you throw parentheses around this, and then show that you're subtracting. So x squared minus x squared is nothing, which is what I wanted. I couldn't move on if I didn't. And then I have negative 5x minus negative 4x. Well, this changes this into a positive, since a negative makes positive. So negative 5x plus 4x makes negative 1x. and then I bring down my remainder, or I bring down what's left, which is negative 20. Okay, and now I want to get, now this is the term that I want to get rid of, negative 1x. So whatever I put above this 20 has to be a number, and I want to be able to multiply by x to get a negative 1x. So I need to put a negative 1 here. Because notice if I put a negative 1 times x is negative 1x, and those are identical, which means that they'll disappear. Negative 1 times negative 4 is positive 4. I put parentheses around this whole thing and subtract. So again, notice a negative, I'm going to do negative 1x minus negative 1x. Well, then this changes into a positive, which is why those cancel. And then negative 20, and notice I have to go, I'm going to keep going back to this. I don't want to do negative 20 plus 4. It's negative 20 minus 4. So this is negative 24. And then that's my remainder. So before I wrote my remainder like this and said remainder of negative 24, you're going to be writing your answers like we did in the last problem. Oops. So you're going to say that you got x minus 1, and then instead of saying a remainder of negative 24, we're going to say plus negative 24 over the divisor of x minus 4. So this is my solution. Okay. Let's try it again. Alright, so again, write it out. Give yourself some space. So x squared plus 3x plus 5 divided by x plus 1. Okay, again, whatever I put on top of the x squared has to be a like term. So if I put an x squared here and multiply x squared times x, I get an x cubed, which will not cancel with x squared, so that doesn't work. But if I put something over this x, I can put an x here, and then notice x times x gives me x squared, which is what I want, because then when I subtract, it'll disappear. X times 1 is 1x. Make sure you throw your parentheses around this so you remember that you're subtracting the whole quantity, not just the first term. X squared minus x squared is nothing, which is what I wanted. 3x minus 1x is 2x. Bring down the 5, so plus 5. Okay. I need this to be a 2x, so I need to put something here times x to give me a 2x. So I'm going to put a plus 2. And then notice 2 times x is 2x, and 2 times 1 is 2. And again, I want to subtract this whole quantity. Don't forget those. 2x minus 2x is nothing, which is what I wanted. 5 minus 2 is 3. So I get a remainder of 3. So my answer, when I divide these, is x plus 2 plus 3 over my divisor of x plus 1. Okay, there's a couple more in the back, so let's go do those. Alright, I want to divide 4x cubed plus 5x minus 4 by x squared plus 1. Again, write it out, give yourself some space. There is one catch with this. Notice that here we're missing an x squared term, so when we write it out, we want to show that that term's there. If we don't show it, we lose it, then our answer will be wrong. So we have 4x cubed, and I'm going to write plus 0x squared, that's my placeholder, plus 5x minus 4. And I'm going to divide this. And notice in my divisor I'm missing a term 2. So I'm going to say x squared plus 0x plus 1. Alright, I'm actually going to make one small change to this. Do me a favor and actually erase this. We're going to change, instead of 4x to the third, we're going to change to 4x squared. So this will make it 2. So we'll make this 4x squared plus 5x minus 4. That way we only have one term that's missing, and it's in the divisor. Okay? Alright, so anything that I put above here would have to be like an x squared. X squared times x squared is x to the 4th, so that's not going to cancel. So if I back up and I make this an x, x times x squared is x to the 3rd, so that's not going to cancel. So I'm actually going to go all the way back to here and I'm just going to put a 1 here. Okay, notice if it's a 1, 1 times x squared is 1x squared, but I need this to be a 4x squared, so I actually want to make this a 4. Okay, watch. So 4 times x squared gives me 4x squared. 4 times 0x is plus 0x, and 4 times 1 is positive 4. Put parentheses around this whole thing and subtract. 4x minus 4x is nothing, which is perfect. That means I can continue. 5 minus 0 is 5x. And negative 4 minus 4 is negative 8. Again, not 0. You have to subtract every term. There's nothing left for me to bring down, which means my answer is 4 plus this remainder, 5x minus 8, over my divisor, and I'm going to take that 0 out and just write x squared plus 1. And that's my solution. Okay? At this point, if you want to try one on your own, feel free. Otherwise, you can watch me and I'll do it again. So notice I have no missing terms. So I have 3x to the third plus 16x squared plus 18x plus 8. And I'm going to divide this whole thing by x plus 4. Okay. Alright, I need to get a 3x to the third to cancel. So in order to get an x to the third, I need to multiply x by x squared, and I need it to be a 3. So I need a 3x squared here. Okay. When I multiply 3x squared times x, I get 3x to the third, which is what I wanted. 3x squared times 4 is 12x squared. Notice that everything that's lining up are like terms. You should always be having like terms line up. Okay, subtract this whole thing. Make sure you have parentheses. Subtract my first two terms. They cancel, which means I can move on. 16 minus 12 is 4x squared. Bring down my 18x, my positive 18x. Okay, now I need a 4x squared to cancel. So I'm looking for what times x gives me 4x squared. Well, I need a 4, and the only term that this could be is an x, since it's over an x. So 4x times x gives me a 4x squared plus 16x. Put parentheses and subtract. My leading terms cancel, which is what I wanted. 18 minus 16 is 2x. And I have to bring down my 8. So plus 8. Okay. Now I need a 2x to cancel. And over an 8 can only be a number, so I need this to be a 2. So 2 times x gives me 2x and plus 8. Subtract all of this. So notice 2x minus 2x cancels, 8 minus 8 cancels, and I get left with a remainder of 0. So that means when I divide these, my answer has no remainder. It's 3x squared plus 4x plus 2. Alright, the fact that there is no remainder, we want to make note of this. That means that x plus 4 is a factor. So that means if you were able to factor this out, so that means you can factor this out, and x plus 4 would be a factor. That also means if x plus 4 is a factor, if you were to subtract 4, that means that x equals negative 4 is a solution. So that means if you were to graph that function, your function would hit at x equals negative 4. Okay, so anytime you get no remainder, it means that it actually is a factor of the polynomial. Okay, let's keep moving on. Alright, notice that this one has a lot of missing terms. So we have x to the fourth. We're missing x to the third, so I'm going to write 0x to the third plus 0x squared. And then I can pick back up and write minus 13x minus 42. I always want to have placeholders. Divided by x plus 2. Okay? So I need to get rid of an x to the fourth, and I multiply by x. So I can do that by putting an x to the third here. multiply x to the third times x, I get x to the fourth plus 2x to the third. I want to subtract these. You would know that you missed a placeholder here if you do not have terms lining up that were like terms. So notice these are like terms because I put that placeholder there. Okay. My first terms cancel. 0 minus 2 is negative 2x to the third. I bring down positive 0x squared. Okay, I'm looking for a negative 2x to the third. So this has to be a minus 2, and it's got to be an x squared since it's above the x squared. Negative 2x squared times x gives me negative 2x to the third minus 4x squared. Okay, I want to subtract these. Negative minus a negative, that becomes positive, so those cancel, which is great. A negative negative makes this a positive 4x squared, so 0 plus 4x squared is 4x squared. Just be careful with your handwriting here that things aren't getting too smashed together, because then we start losing positives and negatives, and things start disappearing or changing. Alright, bring down your negative 13x. So now I need a 4x squared, which means above this I want to have a plus 4x, again like terms. 4x times x is 4x squared. 4x times 2 is 8x. Parentheses around it, subtract. First terms cancel. Negative 13 minus 8 makes negative 21x. And then I want to bring down the negative 42. Okay, I need a negative 21x. So this has to be a minus 21. Okay, multiply that. And a space here. I get negative 21x plus 42. Put parentheses around it. Subtract. Alright, my first terms cancel. It's very easy to put a 0 here because we see a plus and a minus, but remember this is negative 42 minus 42, which makes negative 84. Okay, so my answer is pretty long. My answer is x to the third minus 2x squared plus 4x minus 21 plus negative 84 over x plus 2. Okay? And if you wanted to, you could write, oops. And if you wanted to, I always circle these because once you start getting all this work in, it starts to become messy. So that's my answer. If you wanted to, you could actually replace this plus sign with a minus sign and just write 84 for x plus 2. But I don't care. Alright. Next problem. Last problem. Alright. Notice that I have a to the fourth, to the third. I'm missing a squared. So this would probably be a good time for you guys to pause it. Try one problem at least on your own if you haven't already. And then check back and see how you did. Okay, so I have a 2x to the fourth minus 6x to the third plus 0x squared plus 5x minus 1. And I'm going to divide this whole thing by a trinomial this time, which I ran out of space. So I'm going to divide this whole thing by x squared minus 2x plus 2. Oh, sorry guys, I just realized I had a mistake in the last problem too. Up here, when you have a negative 21 times 2, this should have been a negative 42. Sorry about that. And when that's a negative 42, now you have a negative minus a negative, which makes this a positive, which means that the remainder is 0. So this should have been a remainder of 0, which means that there is no remainder here. Sorry about that. So then this is your answer, which means the same thing happens from up above, which means that this x plus 2 is a factor of that polynomial, which means that x equals negative 2 is a solution to that x to the fourth minus 13x minus 42. Sorry about that. All right, so continuing with this function over here. Myself some room here. Okay, so we got to figure out where to start. We need a 2x to the fourth to disappear. So I'm trying to think what times x squared would give me an x to the fourth. So I'd have to jump all the way over here to this x squared. Okay, x squared times x squared is x to the fourth, but I need to make this a 2 so that it becomes a 2 like this. So 2x squared times x squared makes it 2x to the fourth, which is perfect. That's what I wanted. So now I'm going to continue. 2x squared times negative 2 is negative 4x to the third. And 2x squared times 2 is plus 4x squared. I'm going to put parentheses around the whole thing and subtract. My first terms cancel, which is perfect. This negative and negative make a positive. Excuse me. So that's a positive. Negative 6 plus 4 makes negative 2x to the third. 0 minus 4 makes negative 4x squared. I'm going to bring down this positive 5x. Now I'm looking to make a negative 2x to the third. So in order to make it a negative 2, I'm trying to multiply by that x squared. I need this to be a negative 2, and then it's got to be an x since it's above that term. So negative 2x times x squared is negative 2x to the third. Negative 2x times negative 2x is positive 4x squared. Sorry, squared. Negative 2x times 2 is negative 4x. Put parentheses around the whole thing so I can subtract it. My first terms cancel since this becomes a positive. Negative 4x squared minus 4x squared does not cancel. It's an 8x squared. 5 minus a negative, so this becomes positive 4. So then this becomes positive 9x. And now I want to bring down my negative 1. Okay, I need to get a negative x squared. Let me move this out of here. Okay, in order to get a negative x squared, I need to have a negative 8 up here. It's a negative 8 for some reason. Alright, negative 8 times x squared makes negative 8x squared. So those are going to cancel, so I'm going to continue. Negative 8 times negative 2 is positive 16x. And negative 8 times 2 is negative 16. I'm going to put parentheses around the whole thing, write subtraction. Again, don't forget that. These two are going to become positive, which makes that cancel. 9 minus, this is a 16. 9 minus 16 is negative 7x. And this negative and this negative are going to make a positive, so 16 and negative 1 makes positive 15. So in this one, we do have a remainder. Okay, so my answer is going to be 2x squared. 2x squared minus 2x minus 8 plus negative 7x plus 15 over my divisor, which was x squared minus 2x plus 2. Okay. All right. And then for your homework, you guys are going to do a lot of the same, and you're just going to practice long division. Okay. The only way to get it is to keep doing it. So you have 2 problems there. You have 2 problems there. Make sure you look for placeholders. You have 2 problems there. So that's 6 problems. And you got 2 more in the back. So you got 8 problems to practice. And then I put some review in here that I thought you might need after the quiz. And then some more graphing as a review as well. Okay? For these first 8 problems where you're doing long division, if you don't think that's enough room, don't cram it in. You're going to end up losing positives and negative signs and stuff like that. Just use a scratch sheet of paper. And then you can give yourself as much space as you need. Okay? All right, I will be back on Thursday morning if you guys have any questions and want to go through this. On Thursday, we're going to talk about another method that you can use to solve a function.